No, I was checking.
Should we,
Hello, everyone, and welcome. I'm Sarah from the Green Register, and thank you for joining us tonight at our Twilight Talk. So tonight it's Insulation 2.0. Insulation just needs to insulate right? Wrong. So we've got Joe Pritchard and Jeremy Hayden from Mike Wye joining us, and in a moment I will be handing over to them. But before I do that, I just want to outline a few housekeeping items. So microphones, if you could just keep them off while the speakers are speaking, just so we don't pick up on any background noise or anything from you guys. Videos, it's up to you whether you leave it on or off, but it's really nice for the speakers to know that who's here, who's listening, and for them to see your faces. So it's your choice, but please do consider leaving them on. If you've got any questions throughout the session, feel free to unmute your mic and ask it. Sometimes it's good to ask questions as they come up, but if you'd rather not, or if you haven't got a microphone, then feel free to just drop it in the chat and we will get to it at the end of the presentation. But the speakers are happy to sort of it be a bit conversational tonight with the format of this session. If you've got any technical issues, drop me a message in the chat and I'll do what I can to help. Sometimes with internet issues and connection issues, if you turn off your camera, it can help, but anything else, just let me know and I'll do what I can to help. After the session, we send out a feedback form, and I know everywhere asks for feedback these days, but it really is helpful for us to know what you enjoyed about today's event and what you'd like to see us do more of. So please do consider filling that out and getting it back to us. It'd be great. We'll also be sending out a copy of the recording for tonight's event and speaker presentation, as well as the chat transcript from the session. Just finally, if you could make sure that your Zoom name is the name that you booked on with, so that my lovely host Elaine, co-worker Elaine, can pick you off on her sheet. But I think that's everything from me. I will hand over to Joe and Jeremy to start. Thank you very much, everyone. Enjoy the session.
Thank you very much.
hello, everybody.
So, good evening, everyone. I'm just going to move this over. Shall we share on the screen? And there.
Should be a bit.
So hopefully you can all see that now and it's all clear and we can get underway. Maybe first of all, introduce Joe and myself. We both work here at Mike Wye in the insulation team. Joe's been here slightly longer than myself. Just for any that don't know, we are a builders merchant. Sustainable insulation, it forms the backbone of the business here now. But Mike has been looking after old buildings for 30 plus years now with their own range of limes and mortars, and it's just grown from that. So, as I say, if there is, sorry,
Yeah, well,
we'll work through. If there are any questions that you want to ask as we go along, that's obviously fine. It helps us. We like to think we can keep things on track then. If there are any longer and more involved ones, if we could leave those to the end, we'd be happy to field anything that comes up then, if that's okay.
So yes, welcome. Thanks for turning up, everybody. In droves, some recognisable names, some familiar names in the chat. So hello to you guys. If we've been speaking with you about projects, then it's great to see you here today as well. And as always, if any of you are speaking with us already, or you want to talk to us after the event, or just ask us some advice about any of the products or topics we cover, feel free to email us that. We'll drop our email contact details at the end, and we can go into more detail about your specific project. But yeah, welcome along. Thanks for being here. And I guess we should get into talking about some insulation, really, shouldn't we?
Best had.
Right, by all ages.
So, what have we? some brief areas. We're not going to stick to this absolutely. There's some that's more interesting than others, but just really what we're going to go through is what is natural fibre insulation, common types available in the UK, the reasons we use it, and the benefits of multiple roles of it. You'll see it's much more versatile than perhaps many people think. We have got a couple of typical construction examples at the end. Now, these are a couple of examples that Joe and I tend to deal with most days. There are obviously a huge variant on that. So again, if you wanted to see something else, then let us know. And if not tonight, we can certainly pick up that with you over the next few days.
Yeah, just quickly diving in on the focus of this is like insulation does more than just one thing. I think that's very much the theme of the chat today. I was desperately trying to think of a good analogy throughout the day. I didn't come up with anything too fantastic other than the fact that I tried to liken it in my head to maybe buying a car, for example. I think if you're buying a car, there's probably many different things you take into consideration before you make your final decision, as opposed to just one. And we get that here quite a lot, where someone's on the phone or they fire in an email, and the focus of that email, or very much the only thing that's brought up, is the U value. It's like, what's it going to do for me from a U value perspective, which is obviously a very important thing. It's one of the most important things that insulation can do for you, but it's by no means the only, and it certainly should. Many other factors should kind of figure into your decision making process. If you were to just buy the cheapest car, I think we all know what would happen there. You wouldn't spend much money, which would be great, which might be a priority, but the car might be a complete disaster. So it's thinking about it through a multifaceted lens. Not a blinkered view. There's much more to insulation than just U values. So I think it's just a question of really understanding that and making the best all-round decision.
So, natural fibre insulation, this is glaringly obvious, I'm sure, but it's sustainably sourced plant or animal fibres. Been mechanically processed with minimal additives, so we're looking to keep that as pure for natural fibres as possible. There's a huge range of applications for the various parts of the building. And we cover, immediately for me, you think of the natural fibres, we're looking at the woods, the hemps, wool, basically anything that's not foam. Now that may be used then in roof and wall build-ups, but also we do carry some, not strictly speaking of natural fibre, but some other initiative products, but probably won't touch on that today unless someone specifically wants to see them. So the wood fibre, Debbie McGee's going to.
Well, I'm a glamorous assistant. I'm sure a lot of you would have seen these products. Maybe you have, maybe you haven't. So it might be a good idea to just get someone on camera. So we've got a couple of examples of the wood fibre. We've got a sample of sheep's wool, and we've also got a novel thing that we've been sent recently, which is made out of wheat. But as it says there, there's loads of different ones that are weird and wonderful coming up with all the time. And obviously there are insulation solutions out there that aren't natural fibre. We're going to focus on those primarily today, A, because that's what we know and love, and B, because there just seems to be more innovation in that kind of arena, which is I guess which is a good thing. So just quickly, wood fibre, a couple of examples. We've got this one here. So this is a small sample of an infill material. It's actually got quite a lot of squidge to it. So again, think of that as a direct replacement for something like a mineral wool or a fiberglass roll or slab that would tend to go in your timber frame walls, or perhaps in between your rafters, or even just on top of your ceiling to insulate your loft. That's a really good substitute for that, and because it's got that kind of squidgeability to it, it just friction fits and presses into spaces and nooks and crannies, and you can cut it and shape it and all of that. So it's a very versatile thing. That's one type of wood fibre. There are many different boards and shapes and sizes, but the main thing is the flexible stuff, which goes in your frame, and then a variety of different boards. This sample board has got a tongue and groove profile, so that interlocks nicely. So that would be used to span across a timber frame, maybe over the top of a roof, maybe on the outside or the inside of a timber frame wall. There are square edge boards as well that can just be butted up next to each other and secured directly onto a solid masonry wall. Again, I'm pretty sure a lot of you will have come across that, but that's a really common one, is the solid wall insulation, and the wood fiber boards are a great solution to that, but by no means the only one. But we do have those here handy, so we brought them along just to show you. And yeah, there's loads of other ones. There's the hemp, and they're making stuff out of recycled kind of jeans and stuff, and there's all sorts of textiles. So there's loads of things coming out in that world. But obviously there are situations where, you know, your bog standard stuff that you're maybe more familiar with is still as good, or maybe even a better choice for that particular situation. So it's all situational, and again, it's all about making the right decision based on a number of factors, which is probably going to be finalized once you've just got a good understanding of what you're trying to tackle, what you're trying to do. I think that's where a lot of people go wrong. They're not really thinking about what they're trying to do, other than just, we need to insulate. They know they need to insulate, it's a great thing, but there are, you know, there are means and ways of insulating something in a more proficient way than others. So yeah, there we go. That's various different types of natural fiber insulation.
Come on there then to look at the different roles that were filled. As Joe's just said, people's primary concern is the thermal insulation. But what we find with the natural fibres, particularly in conjunction with the older buildings for retrofit, but more and more now with new builds, its performance in all these other areas is pretty impressive as well. So whether that be acoustic, due to the nature of its makeup and its mass, is able to absorb sound more. Its fire performance is pretty impressive. We will go through each of these, so don't worry, we're not going to skip over. The health benefits, which I think is something we're all becoming increasingly concerned with now, and probably I will have tales of the difference in feel and people's health from living in-house, made of natural materials rather than petrochemical foams. In terms of its comfort, as well as insulating, a lot of them have great thermal performance in preventing particularly roof spaces from overheating, so it's able to manage that better. Sustainability probably goes without saying, it's what we'd all expect as a minimum from it, and its durability. Yeah.
Sorry, folks. Yeah, small disruption.
So yeah, we'll cover all of those as we go through.
Whistle stop.
So it's very much more than just a U value. I think people, particularly now where they're looking to insulate a modern home, they're looking at maximum U values and perhaps not aware of the other benefits and also the other problems potentially that insulating can cause. So start with the main one.
Yeah, well, again, just to drive home, obviously this is a massively important part of your performance of your insulation, is how well it insulates. A lot of you will probably be familiar with lambda values and U values and things like that. And some people may be a bit skeptical, or they're just not even aware that you can actually quite easily achieve some very good U values, or the type of U values that you're going to need to, you know, that might be passed upon you by building control. They can, no problems, be achieved from these slightly lesser known or more novel products. A lot of them aren't actually that far off some of the high performing foam boards, which a lot of people go to because they are higher performing, but they're not necessarily that far behind. So you get a lot of other benefits, and makes these a really good option to consider. So the U values or lambda values of the highest performing products are generally around the sort of 0.2, 0.25. The flex wood fiber here is at 0.036, so it's not a million miles behind at all. And the boards are, you know, in a similar sort of ballpark. So you can absolutely get to where you need to be from these products. And that's something that maybe some people are sort of slightly unsure about. So don't be afraid. Yes, you can use these. Yes, you can meet what you need to meet by going with these instead.
So it's showing here an evolution, not just about thermal conductivity. As I mentioned just a moment ago, decrement delay. What they're able to do is absorb that heat throughout the course of the day, with a heating cycle there, and then gently release it. So your buildings aren't going to become overrun. There's down to their thermal mass. So they're able to absorb that and release it slowly. So you're not going to see it effectively flattens the curve. It's not going to see the spikes that you would see in hot days versus cold days there. So it'll hold it more comfortable level all the way through. So it protects against the summer overheating. Moving on to perhaps the reason that certainly one of the main reasons that we come to use it here, particularly in conjunction with old houses, solid construction houses, is its ability to manage the moisture. Rather than blocking the insulation from moisture and using materials that need to be wrapped up and sealed, the materials here are able to manage it. So they'll help the transport of any moisture from within the building externally.
Yeah, I mean, without a doubt, like the word breathability gets thrown around all the time now, but people are like, well, what does that even mean? Breathability is essentially how vapor open something is. It's something's ability to allow moisture vapor that's knocking around in the air to pass through it, as described there. And it's very much a buzzword. People ring up, say, all right, I'm looking for this insulation. I've been told I need breathable insulation, like without necessarily truly understanding what that even means. So, we all know that's important. Moisture getting into the nooks and crannies where you don't want them in your building is potentially catastrophic, and is actually one of the most common reasons for, major building defect like problems. It's extremely common. So again, just thinking about it in advance, as opposed to just going for, all right, what's going to be the most effective in terms of thermal resistance? Are we potentially solving one problem but leaving ourselves wide open to another? And again, we've seen that over the years. There's been various schemes. Again, I'm sure you're all well and truly clued up on this, where other types of insulation products have been installed, probably with the best of intentions and with the right ideas at the time, but 10, 15 years down the line, it's been found out that actually they have been part of a later problem. So they solved the insulation problem for a short period of time, but they caused other moisture problems. So it's very much a case of picking something that's going to do all the jobs and ideally not set you up for peril down the line. So that's essentially what is meant by breathable. I'm sure you're all aware of that. Hygroscopicity is slightly lesser known. Again, some insulation products will have the ability to, they will be hygroscopic, and some won't. And hygroscopicity is a material's ability to basically buffer, to bind and absorb moisture to a certain degree while the environmental conditions are put upon it. It means it's necessary, but it also has the ability to then sort of discharge and release that moisture over time. So it can be very, very useful to help you manage that moisture. Whereas again, products that don't do that, they're very good insulators, but if they're not helping you out in that fashion, they could be causing other problems. Capillarity is a similar sort of in the same vein, in so much as that the natural fibrous products, they will have the ability to again move moisture that might be forming on one spot and draw it through the material and then discharge it through evaporation or diffusion or what have you through a later stage and back into the environment for extraction or ventilation. So you're not getting that moisture trapped deep in the heart of your fabric. That's something you're desperately trying to avoid, essentially.
Sorry if it seems like it's jumping on a bit, but health is another major factor here, and I'm sure we've all got tales. Certainly, I've seen some from first-hand experience with my wife with asthma and living in a rental property where there was problems there. And over time, I'm not sure the general age of the group today, but I think we're all old enough to look back. And I certainly don't remember seeing the number of people on asthma inhalers to the extent that we do now. It's pretty much a lot. And I'm sure that's not coincidental with the problems that we've stored up, perhaps with some of the foam installations or lack of thinking with regard to the detail on these products. So it's important for us, the amount of time we spend inside, obviously it's important to have that environment in a good, healthy condition, a good air quality, that's going to give us the best chances to make it through to a longer life. So we're looking at various different aspects of this now, particularly I think the mold and fungal exposure, where we've all seen examples again on various different training courses, some of us firsthand, where there's been a build-up of condensation within the building fabric and consequent mold growth and surface mold growth as well. Used correctly, inspect correctly, and going back to what we're saying about not the instinct to over-insulate, then we can manage that to a huge extent. And that's a big part of what we do when we're trying out various different build-ups through our software and simulations to run that through. And we like to think that we're able to offer confidently solutions that will work and will be proven to work. Now, that's not to say we don't come under pressure a lot of the time to, we want to put more insulation, and people are pushing that all the time. And we're all for it. Believe you me, if we could sell everybody thicker insulation, we'd be happy doing it. Frankly, we'd make more money. But we're looking to sell a product or sell a solution that's going to be the right solution for each property and each person, each customer.
It's no good for anyone down the line if they, if the solution actually, as I said, solves one problem short term, but then causes another. Black mold is a classic. It's a very well known one, as well as being kind of unsightly. We're talking about respiratory issues that obviously this is well talked about. There's numerous news exposés and things like that about dodgy landlords or what have you, where this is an issue. And again, that's largely down to high humidity. So again, the right types of insulation. Again, not just purely banging the drum about natural fiber insulation, but they do offer so many broader scope of benefits that they deserve to be talked about quite frankly. So yeah, so that's a big tick in that box as well. And let's talk about quickly about volatile organic compounds. That's essentially chemical nasties that might be within the recipe of the product. Sometimes products will be what's known as off gas, which is small, or it's deterioration essentially, where some of the chemicals or what have you that goes into the product will kind of leach into your internal environment. So as well as stopping mold and things like that from becoming apparent, it also doesn't kind of add into the mix anything unpleasant from its own, just from its own presence, I suppose. Just quickly, Imogen's had a question. Hello, Imogen, how are you? Hope you're well. I thought the moisture limit for Styco was 18 to 20%. Yeah, it's in that ballpark. Styco has suggested that up to 24% is okay. I think 18 to 20 is kind of the kind of average in ambient conditions. I mean, obviously it can get way more moist than that and actually be fine, but you wouldn't want it much above 20, especially not beyond 24 for any elongated period of time. In a short space, it can get damper than that, but it will dry out. If it's in a situation where it gets to that, but then the saturation is continuing and it's got no opportunity to dry out, then you're in trouble, because if it gets above a certain point, then you get mold growth and you get degradation. So in isolation or in pockets, it's okay for it to dip above those numbers or just kind of jot above those numbers, but you certainly want to keep that as an ideal threshold for the vast majority of the time.
Something I think I've probably glossed over too quickly. These, when we talk about the breathability of materials, that's not a substitute for adequate ventilation. They're good, but they're good up to a point. So you must ensure, if they're being used, particularly in rooms where there's like to encounter high levels of vapor and moisture, that there must be adequate ventilation systems used in conjunction with them.
Yeah, for sure. I mean, that's still your first weapon in your armory to deal with moisture, is extraction and ventilation. You don't want to rely on the fabric being breathable. It's good that it is. It's another tool in your toolbox, but that's not your go-to. If you've got moisture issues, then probably change the behavior. I think you'll, again, kind of preaching to the congregation here. But open the window after you have a shower, make sure extraction fans work, etc. Avoid that moisture overloading problem. These will help, but they're not your first go-to.
acoustic insulation. We get asked about acoustic insulation more and more now. I think part of the aspect is it's a key part of life now, where you see, particularly with new builds, where they're built on, frankly, cheaper constructions, it is an often raised issue by new homeowners. Now, what you'll see with the wood fibre in particular, the cork is very good as well, but also these, due to the nature of their build-up and their shape, they're essentially irregular structures to them, so they're not going to reflect things in the same way. They're more inclined to absorb them, but also they're a lot denser than the foam fabrics. So again, they will absorb sound. Now that's very good for transmission of sound between rooms. The other thing we see sometimes is some of the materials we use here. We use a wood wall board as a render carrier and a breathable alternative to plasterboard. They also make a finished version of that, which is used for reducing the acoustic within a room. So that would be more for a room treatment, such as a studio or a noisy office or a library, where we can deaden those. But the wood fibre and the natural fibres certainly play a huge part in that transmission of sound beyond the build-up. Sustainability. It sounds obvious, but natural fibres are better at this than foam insulations. Basically, all of the for us, if we can talk about Styco briefly from it, Styco's main product line would be their internal timber beams, which is essentially two plywood build-ups of a timber with a hardwood type material in between, an I-beam. Now, obviously, for construction of that, where there is a structural component, they have to be up to a certain level of strength. But also in the production of those, there's a huge amount of processing for the wood fibre. Consequently, you're left with material in the workshop, which is then repurposed into these wood fibre insulations. So it's brilliant in terms of getting the maximum yield from those materials as they're harvested, but also for the ones as they're grown, where they don't quite meet the strength kind of qualities needed for a structural component, we can use them in the insulation.
Yeah, and ultimately they're infinitely recyclable, or you can I know it takes a while, but you grow more trees. The growth of tree sequesters carbon, so you're kind of, before you're using it up and kind of chopping that tree down, it's absorbed carbon from the atmosphere. So I'd love to say it's carbon negative. It's not. There are some products out there that are nearest damn it, and the wood fibre has really got a very low carbon footprint. But compared to the petrochemical products, which again have their place for sure, but yeah, they will have a higher carbon footprint. Let's just whiz through a couple of questions, Jez.
All right. Okay.
I think Astrid. Hi, Astrid. Yes. How do I know what thickness the insulation should be? Look, so U values, absolutely. Drop us an email. Our emails are, well, it's just insulation@mikewye.co.uk, or just jump on our website. I think you can submit a contact us from there. We will run U value calculations for you, no problem. We started dabbling in hygrothermal modeling, which is a bit more in depth, and we're kind of starting to dabble in that, which we're happy to have conversations with you about, but that's a far more murky waters. It's a very complex thing. So, but U values are fairly straightforward and fairly reliable, so we're absolutely happy to run those for you. Typically speaking, I mean, there is no typical thing really, but I mean, we're happy to run through kind of like common U values from approximately what thickness you'll need. But yeah, absolutely, you insulate suspended timber floors, timber frame walls, solid walls,
roof build-up.
Yeah, obviously roof build-ups in terms of pitch roofs, if you've converted the roof, if you are going to convert the roof, or if you've just got a standard loft insulation, just whack it between your joists and then 90 degrees, roll it out and go across the other way. We can talk to you about the uses of membranes to help, again, further with air tightness. Again, just quick shout for air tightness that doesn't get enough love. Air tightness is massively important. You can insulate, yay thick until you're blue in the face, and you can use the best insulation out there. But if you leave air gaps, you're leaving yourself wide open to huge amounts of heat loss through convection. So it's really, really important that the quality of the work is as good as the quality of the product, I suppose. So yeah, it all interlinks, but yeah, air tightness, thickness of insulation, types of membranes, types of insulations. We're very happy to advise on all of this. There are generic build-ups on our website. We might run through a couple at the end if we've got a bit of time. But hopefully that answers your question in so much as that, yes, you don't necessarily need to have an architect or some genius. They're fairly easy calculations to run.
Regard to the certification, it's something that came up recently with the show in Birmingham, where people have said they had struggled with whether build-ups are not necessarily recognised as standard build-ups. They're becoming more and more accepted. I know Styco are ongoing doing work on all of these in order to promote the products, frankly. But yes.
And I've not had any instances where someone has actually had an issue with getting a mortgage, or you know, were denied it, or they were warned off of it because of using natural fiber insulation. I've certainly heard about it with some spray foam applications where moisture was being trapped. That's I've come across, and you again, this is a classic where things were done with the best intention at the time, but they've turned out to be problematic. Spray foam in attics is one of those examples, as is, you know, blown in cavity wall solutions. I think we're all aware that those have had some issues. Just a quick one, haven't Styco been bought up by Kingspan? Yes, they have. However, they're still churning out the wood fiber and doing their thing. So we're going to continue selling wood fiber, whether it's through Styco, which I assume it will be, for some time. It's an excellent product and it does its thing. I mean, you could potentially argue about those two things conflict, potentially, but ultimately Styco is still making wood fiber, and wood fiber is still an excellent natural insulation choice, and we're going to keep you know, singing its praises. So yes is the answer to that. What their long-term plans are, who knows? Maybe they'll completely diversify and just do wood fiber one day. Who knows?
We'll see. Ultimately, certainly from our experience, the actual interest and the growth in the sales of this market overall has been such that I can understand why they've bought it. And so we continue to invest in it. So in the time that I've been here, less than 2 years now, I've seen the warehouse and the stock holding double. The insulation team itself is nearly double in size now, and making the investment, as we were saying earlier, in the woofy training and various training courses for us to keep going in this direction.
Indie Nature Hemp loft insulation has been okayed. Excellent. Yeah, I mean, I sort of not really come across any instances where the natural fiber products have been really kind of questioned. But obviously, the more and more certification that's official is only going to help the cause. What do you think of corkboard? We love corkboard. Sometimes the availability of corkboard isn't all that great, but again, it's another fantastic natural product. It's extremely resistant to moisture, which can be really, really helpful for certain instances. Jazz, anything to add on cork?
No, in terms of its performance, it's broadly similar to the wood fiber boards in terms of its values. As Joe says, there are certain instances where it's more suitable than a wood fiber would be, perhaps, particularly, as you said, in potentially occasionally damp areas. And exactly as you've asked there, yes, it can. It will manage it and it won't break down, but it will need an opportunity to breathe, and the same as any fabric would.
The other thing, obviously, cork is aesthetically pleasing, so you can get, you know, you can get specially designed ones like that had certain patterns and things cut out of them, so you can just have the cork as a finish. Whereas the wood fiber would almost never be left as just as a finish. It would always need to be covered or plastered or clad or what have you. So yeah, that's the other advantage of cork, because it looks really nice. It's extremely tactile, isn't it? Cork is a great thing, and also granulated cork can be used. So yeah, we also sell cork. Sadly, I didn't have, because it's so expensive, I didn't have a scrap knocking around that I could bring in with me. So full boards only. But yeah, we use cork in various applications, and you can, to a degree, interchange it with wood fiber. Just tend to be more expensive, so people lean towards the wood fiber, which kind of makes sense.
I can probably locate a cork if you need one, but just a single one, and it might not be quite the same.
Well, then, yeah, we can probably go and scurry around in a warehouse quickly.
Wool insulation, I'm sure many people are aware there has been in the fairly recent past quite a large court case with regard to wool and moth infestation on a large property in London. That formula has been changed now. It's not the same material as it was then. We still carry and use fleece insulation. Very popular. Again, in terms of performance, very similar. I think these two are within a tenth of each other in terms of the thermal performance.
That's the wood fiber
sorry.
and the sheep's wool, by the way.
Yeah. So the only occasion where we see, an occasion where we perhaps see wood fiber outperform would be if it's used in a vertical one, whereas the fleece has to be bought in a bat for that, and that makes it slightly more expensive. But other than that, they're broadly very similar.
Yes, borax, I believe, is part of the recipe. That was the upgrade or the change to the recipe, where it's previously just pure sheep's wool, and no chemicals, which was again a good thing. But it turns out they, after they had a couple of instances, it's still not, it's not a slam dunk. It's a case of, I'm sure you get infestations in properties that don't have sheep's wool, but because there was one high profile one, it then got that bad reputation. So, like, put it this way, we have warehouses full of these products, and we've got no infestations.
Yeah.
It's a question of just making sure you don't let an infestation happen in the first place, which is just responsible maintenance of your property, quite frankly. And that could happen almost regardless of what materials have been used. And I've certainly had people say to me that they've had foam boards that, if a rodent finds a foam board, it's going to chew it, it's going to make a home in it. It can do that to any insulation product, even smaller pests can have the same thing. I think probably even, we're going to go down the road and stop talking about termites and things like that. I've certainly had people say to me that they numerous times have been removing foam boards, and they're not as they're as probably as prone to infestation as anywhere else. It's just a question of not letting the infestation happen in the first place by good initial installation, and then just responsible maintenance of your building.
You said about what's the best plaster type. It comes no surprise for a company that started off making their own lime mortars. We're going to recommend a lime plaster. We find that in many instances, particularly with therm type board for an internal build-up, that will be bonded to the wall, the lime mortar, an NHL based mortar, very thin, only 3 mil, and then the external finish, or the internal finish on the external edge of that build-up, is again internal lime plaster, which is essentially 2 3mm coats for the base coat, and then a 2mm finishing coat with a slightly finer aggregate. And that provides then the breathability. When that's used directly onto the boards, and most of the Styco rigid boards are able to take a direct render, that also then will perform the function of the vapor control layer. So you can remove the need for a membrane, unless you're incorporating some more spaces and things then for service voids. Again, it just comes down to the correct detailing at the outset to make sure that's a sealed build-up and it's going to work for you.
Yeah, for sure. Lime, I mean, it's significantly more breathable than anything sort of like cement-based. Obviously, pure lime in an ideal world, but NHL is not a million miles behind in terms of breathability. So we tend to spec NHL lime finishes, lime plasters.
We have got some results as well from some of the clay plasters as well, if people want to see those. Very popular for aesthetic and has some great sound absorption capabilities as well. So there's a range of them, but again, it can be quite specific case by case. So we can give advice on that if you've got something particular in mind.
Hempcrete box, Michael. Hello, Michael. I think we've spoken. Good to see. I mean, never say never on the hempcrete blocks. We just haven't really got into hemp a huge amount. I think I suppose you only want to have so much diversification within your within your range, or you might start confusing people. Yeah, I mean, hempcrete is another good option, and it's just we've got nothing against hempcrete blocks. It's just not something we currently do. Perhaps the powers that be looked into it and they just thought, well, it might have just purely been a cost thing, or maybe it didn't necessarily add anything more to what we already do. I couldn't give you a straight answer exactly as to the reason why, but there's nothing wrong with them. That they're used, and they can be used in combination with wood fiber as well. So there's nothing wrong with doing that. Jez, do you want to take Charles?
Yeah, not really, Charles, if we're honest. On most of the constructions there, we would be looking at other options for that. Obviously, there's the blown type ones, which can be used, but probably not best suited to it. The only product we carry here, I'm not sure if we call it a natural product or not, in as much as it's recycled foam glass. And we've seen the use of those. Some of you may be familiar with it for use as a floor substrate on the geocell type build-ups. But it's also available in a smaller bead, 2 to 4 mil beads, which we have had some clients use as a cavity fill, particularly on garden rooms where there's a low cavity wall to the lower section, and they're able to use that in there.
Yeah, wall cavities are tricky, humid, unpredictable spaces, and that probably just erring on the side of caution, going for something natural fiber is possibly a bit of a bridge too far for it. It would be high risk, so we just suggest maybe not doing that. But you can still tackle a cavity wall with these products, but you can either externally or internally insulate, and then you can combine those with, again, I mean, this is what we're talking about. Polystyrene beads get blown in all the time as a cavity fill. I mean, you've got the cavity there. You might as well use it. Just because you can't use natural fiber in that instance because there's moisture makes it probably not a great choice. That's where these other products come into their own. They're a better, safer decision or choice for that particular instance. But yeah, combine them with wood fiber internally, or combine them with wood fiber externally, or all of the above, and you can still tackle and get really good results from unfilled cavity walls and do a really good job and upgrading them. I have 1970s brick built, both ends has insulated.
I think it's covered, isn't it?
Very natural. Yeah, I think that's kind of covered by the same
Yeah.
one. Do you want to do Laura's question?
No. Yes. NHLs. We carry a range of NHLs, whereas the traditional lime putty mortars that we supply are ultimately the way to go if you were looking for a breathable build-up and something that's sympathetic to your building structure on a rebuild. The issues you will have is that it can be very slow, and the overall build-up for those, I think our build-up for a lime mortar based is getting on for 28 mils now before you put a finishing plaster on that, and you can imagine that takes time to go. The NHLs, yes, they do harden. They take a longer time to harden, and that's why when we see it, some of the mixes that we recommend for the floor screeds would be NHL 5, and we would recommend a 2-to-1 mix with sand for that, in order to get the strength in there. But they don't achieve their final strength for much later on in that cycle. Traditionally, in order to meet spec, things are measured at 28 days with the concrete one. The NHL is still hardened at that stage.
They're not as hard as cement,
but it would never get to that hardness.
Yeah.
In fact, one of the standard tests we would use for people when they're asking or looking at old buildings, I'm not sure what it's pointed with, I'm not sure what the render is, you would still be able to scratch an NHL off with a tip of a key. It's whereas a cement you would barely touch it with the same. So yes, they are a more buildable, more breathable build-up than the, but use the right one in the right mix. Don't, argument could be that you use NHL 5 everywhere because it's strong and it's going to go off hard. There's a reason why we have NHL 2 and 3.5. It's to meet those other needs where it doesn't call for such a hard mortar.
We do a lime CPD as well quite regularly. We can probably share that with you. We've got it pre-recorded somewhere. It's not readily available on YouTube, but I think we can just ping it out to people. So if you want it, email into us. We'll see if we can release that CPD to you.
Yeah.
And there's quite an interesting graph in there that shows you the different strengths and the different vapor permeabilities of lime putty based products, NHLs, and then obviously cement based stuff. Yes, I mean, Nick, hi. Yeah, it runs pretty regularly. But by all means, email in, like I said, and say any chance of that vid.
Yeah.
You might
You've
get
drawn the short straw with Joe and
Yeah,
I tonight.
no, actually, because Pete and Tom, our colleagues, ran the Lime CD last week through the Green Register. So obviously, sadly, you missed that. But I believe we might be able to still have something to. If not, it'll be running again soon, I'm sure. But yeah, we can certainly give you some sort of evidence about the difference in breathability between different strengths, etc., and how that all kind of correlates.
Imogen, I think you're maybe getting a little muddled there. When we're talking about 18 to 20%, that would be 18 to 20% water by volume of the for the wood fiber there, whereas the 90% you're talking about there is the relative humidity. So there's two separate measures that we would take against that. Both of those would be factored into any of the WFI analysis that we do anyway, and we could produce the output for that. Of course, there's correlation, but they are different things.
Yeah, happy to have more in-depth conversations about specific topics separately. If you want to do that, by all means, email in or give us a call. Which insulation performs the best retarding fire and why? Do they have certification? Oh, good question. Yeah, fire comes up a lot. Wood fiber is it's essentially it's class E, so it's combustible, and if you set fire to it, it would largely just kind of smolder. The surface sort of carbonizes, and at that point, it doesn't really do much more. It just blackens. But technically it is combustible. It's really a question of used in combination. Again, like I mentioned earlier, that you'd almost never, well, you should really never be leaving wood fiber unfinished. So it would be behind something. So it's then a test of that combination of materials. And because there's almost infinite combinations of materials out there that you can splice together to make a wall or a roof or what have you, it's quite hard to have a fire rating for every single different build-up that exists. So sometimes it just comes down to sort of common sense. If a board is covered by a fairly thick layer of wet plaster, which is completely like class A non-combustible, what does that mean for the insulation? Is its fire rating even immediately relevant? And there's testing ongoing right now between Styco and Baumet. We're in conversations with that. We've got a couple of different videos which show really quite compelling what happens if you blast a blowtorch at lime plastered wood fiber, and it really does quite well compared to other things. But is there an official certification for it? It's in the works, but currently if you watch those videos, you'd find them compelling, I'm sure. But that would be one brand and one plaster and different thicknesses. It's just too many permutations. But wood fiber is very good. As I said, it tends to just char. It tends to just char and carbonate, and it won't go up like a box of matches just because it's wood. That just isn't how it operates.
Although it's wood, and I'm sure some of you will have seen them, there was some videos on YouTube demonstrating some Styco wood fiber. They basically cut 6 sides of a cube of wood fiber, some foam, I forget the other mineral wool, and expose them to a flame. Now the wood fiber won't catch a light; it will smolder and burn, or smolder away very, very slowly. The other benefit as well is, yeah, it will smoke. Nobody wants a lung full of wood fiber smoke. However, I think I'd rather face that than some of the foams and the chemicals within those. The other thing that it won't do is, if you've seen any, Nick, in your example there, if you were to have a foam sheet on there and it's exposed to fire, that will start to melt and drip, and essentially you've got liquid flame dripping down, adding to the spread of fire across there. But also if it's contained within, for example, a SIPS type panel between two OSB boards, the outside of that panel is exposed to a flame. What will happen in there is the foam will tend to break down and melt and effectively become a chimney route, so it can actually increase the rate of burn in there. Whereas that wood fibre is a very localized charring. It doesn't catch in the same way.
I think I'll be very quick to just jump in and add that we're not absolute experts on the fire side of things, because it's still, you know, it's still something that's being tested and looked into by the experts. So obviously it's extremely relevant, and we're on top of what news comes of that testing. But I'm not going to pretend that we're fire experts,
No.
sadly.
The reason that the videos aren't on YouTube, and Cycle have withdrawn them, they're going through a process of going through some more testing. They wanted anything that was available on the internet from them to be in line with the European test procedure. So they're making sure that it's exactly in line. So they're going through that at the moment. We hopefully have a bit more information we can push out soon, because believe you me, nobody wants to have an answer to it more than us at the moment, because it's something we're frequently asked.
Glue that holds the wood fibre together. Actually, some of the wood fibre boards are held together purely by the natural lignins and you know, their own protein and their own kind of their own natural bonding. So it depends what process the board has gone through in its manufacturing stage. In terms of other types of boards, data sheets are available on all of the products that we sell on our website, and you can find the full recipes on there. The actual product escapes me at this point in time, but it's all there in black and white. There's nothing being hidden, and we're happy to provide data sheets which will tell you exactly what you need to know there of it.
Essentially, when we're talking about, again, with the Styco products, some of you are familiar with them, may have seen the therm boards, which are designed to be bonded to a solid substrate. There's two versions. There's the wet and the dry. Now, I think that's not a great name in as much as it has been confused with where the product can be used. But the wet process is essentially produced with no binders whatsoever, just the natural lignins within it. The dry process does use a small amount of a bond in there. Now that achieves a slightly higher thermal value, but it's we don't carry it now. We can still get it, but we found that the wet covers most of the situations where that would be required.
Yeah, it's got superior capillarity, and I think it's also slightly more hygroscopic in terms of how much it can aid you in terms of buffering moisture. So the wet produced boards are slightly more advantageous, so we lean into those. So yeah, Sharon, yeah, no problems. I believe this is going to be released. The video is going to be available on this if anyone either has to duck out or sadly wants to watch it again. Don't do that. But again, please do fire any emails into us. Ask us any questions you like. We are very happy to talk through your project. You know, no job too big, no job too small. Yeah, that's pretty much what we do all day, every day. So yeah, give us something to do.
Do we want to quickly look at an example build-up? We've kind of come off the course a little bit, but not that you've missed a lot. I think it's most of the things we discussed anyway.
I think the most critical build-ups are solid walls and probably flat roofs, because they contain parts of the structure which are inherently non-breathable or are moisture, interstitial moisture risks, I think is the best way to talk about it. So Jez, far away with the...
So this is our typical build-up for a solid wall construction, be that brick or stonework. So we try and get as much information when people come in with a new requirement about the build-up, the makeup of that wall, the materials, the thickness, the orientation. So we would always advise, as anybody retrofit and insulation of whatever type wood, that any problems within the wall are addressed first. So your wall is sound, and also in some instances given the opportunity to dry out where it's been perhaps covered in concrete render on both sides for 30 years and has just been soaking it up. So that you can put these products on fairly soon into that drying procedure, but it will be a lot better if it's got the opportunity to properly settle and any water ingress issues are addressed first.
Yeah, it's critical. Making sure if you have got a damp wall, covering it in wood fiber, even though it's breathable, doesn't get to the root cause of why the wall's damp in the first place. If you've removed what you believe to be the problem, great, but it's probably better to, you know, prove positive, actually test it out and let it dry out and monitor it for a bit before you start covering it with wood fiber. Because if it turns out what you think was the problem isn't what was causing it to be damp in the first place, maybe you've got moisture literally being wicked up through the base of the wall, you've removed a non-breathable render, well done, but you've still got moisture being, you know, soaked up through the base with no DPC. Putting wood fiber at least on towards the bottom section of that wall, still probably not a great idea if it's going to be, you know, continuously damp over the course of time.
Okay, so we'll this is a very sweeping generalization, but if we go through the build-up very quickly, what we would generally see is if you've reduced it back to a bare stone or bare brick, we would advise possibly with the use of an additional hard coat, which will give a stronger key onto the wall. But we would use something like the Cecil RB, which is designed for leveling. That can be built up just as much as is necessary to give you a flat finish. What we're looking to do in any of these build-ups is avoid any cavities, big or small, in behind that. So initially, you want a flat, level surface onto which the boards can be bonded. So that would be anything from 10 to 20 millimeters realistically with stone, brick slightly less. Number two there you'll see is a layer of NHL-based lime mortar. That would be a 3mm layer, put on with a notch trowel, so you've got something then to push the timber panels on, depending on what thickness of insulation we're doing. Sweeping generalization, generally speaking, you're talking probably 40 to 60mm would be the sweet spot for that insulation, and that would get you some way in that range of building regs from 0.3 to 0.7. That's not always the case, and that's why we're happy to look at each and every one as they come in if need be. There's some that is, and it's been good for us as well. We've tested a lot of these build-ups that we believe in. We're able to test them now with the work we improved to ourselves, so we're happy with what we're recommending.
Yeah, you get some surprising results, but again,
yeah,
it all leads back. There's various studies done on this. There's the TWE, the thin internal wall insulation study. There's another one that's called, you know, finding the sweet spot, which is essentially where do you get most bang for your buck in terms of improvement, but you don't lose too much internal space. You're not, you know, piling on the cost. It is between 40 and 80 mils. Generally, all roads lead back to that. There are situations where we've tested certain build-ups and it only had 40 mil and it surprisingly still had an issue. But then there's been other situations where we said, oh, well, let's try it with 150 mil and it's come back fine. So again, these are by no means 100% foolproof, but this hygrothermal modeling certainly gives us a much stronger steer. So 40 to 80, while that's a very good range, don't just take it as read.
The other thing you'll see as well is, like with most things, there are diminishing returns. So if you double the insulation thickness, you will not get double the performance. You're chasing small improvements after a certain point. In terms of the overall build-up, just because you've asked it, Sue, the next stage would be to fix with mechanical fixings. These would be thermally insulated, so you're not getting any cold bridging across that. And then the finishing build-up on there, it amounts to 8 millimeters of plaster. So for a typical build-up, 40 to 60 mil, you would see that within 55 to 65 overall, with all the, even if you were to use the leveling, depending on the degree to which that's required.
So does that cover the typical thickness? Yeah, I mean, that is really bread and butter. We get that exact inquiry multiple times a day. And as I said, more often than not, it all leads back to something like 60, 80 mil. It's really just making sure your wall's ready and in the right condition. I don't know if any of you are tackling this, but it's really common, so it does come up a lot. Make sure your wall's in the right condition to accept or go ahead and do the installation, so you haven't got any damp problems and you're not leaving any non-breathable paints as part of the recipe, because that's bad. That's going to cause a moisture bottleneck behind your insulation. You don't want that. So strip anything off that's going to be problematic. Ideally, let the wall breathe and dry out if you can, if it needs it, and then go ahead with bonding the boards to the wall and then plaster over the boards.
Insulated render, Imogen, I was thinking of you actually. One of the key things we see on the modeling, and you're absolutely right, the modeling is critical on that with the insulation to gauge that. Now, as you can imagine, we are not visiting site and taking samples of the stonework that's there. So we're very much, if we've got something that we think is about right, we will bracket that either side, either by using a different testing the location, or whether we use a more porous stone, just to provide worst case on some of the build-ups to prove it. With regard to insulating renders, we don't currently feature one on the website at all. It's a kind of compromised product in terms of its strength and durability as a mortar. It doesn't perform as well as a pure mortar would. In terms of its insulation value, it doesn't perform as well as a natural fiber insulation would. There are certain instances where we see it's useful, particularly if you've got a borderline case for insulation. It can help as a buffer. You could substitute an insulating render perhaps as the leveling coat here. So level 1 on that diagram there. So sometimes that can help to control the dew point within a build-up of where that's likely to occur. We don't currently have one that would say, yes, this is our current product. We have had them previously, and we do supply them still to some contractors that still use them. So,
Hi, Michael. Sorry, once again, can the boards be directly applied to existing plaster? If it's lime, yeah. Again, as long as it's not been painted or you've not got like a wallpaper over that plaster. If you're really confident that it's lime and it's not going to compromise the breathability of what you're doing, what you're installing, then yes. Belt and braces, take it back to the brick or stone if you can. I understand that can be a really quite an invasive and messy job, but if you're not confident that it's lime plaster on there, then it's probably better to err on the side of caution. But yes, in theory, you can just bond the boards with NHL bonding material back to a lime plaster onto the masonry wall.
It's usually fairly apparent if the mortar that's on there or the plaster that's on there internally is showing signs of breaking down. You could be pretty sure it's not working effectively, because that will be moisture in behind that's causing that. The other thing I would say is if you've got a patch or an area of the room that is particularly damp, it's quite likely that the rest of that will have spread and you're going to see the rest of it break down. It just might be a bit behind in terms of time.
Samantha, yes, absolutely. All email queries are welcome. We're happy to look at and talk to you about whatever you want to run by us. Photos are always helpful. But yeah, give us a call, drop us an email, no problem at all. Dickie, you're welcome. Thanks for turning up. Yes, again, that's another very good point. Before you start doing anything too destructive, if you've got a listed building or a historic building, you might actually getting yourself in trouble if you start removing things that you shouldn't be removing. So a very good point there.
We're often confronted with people, not just in that situation, but there's a misconception that if I put some breathable paint on this cement render and this foam insulated wall, it then becomes breathable. It's paint, it's not magic. It's good, but up to a point. So and also if you, whatever the substrate you're putting it on, unless you could be sure that that is sound throughout, you've got a good key. However good the lime is, however good the clay may be, however good the paint may be, it's only as good as what it's stuck to. And if that is not adhered properly to the substrate behind, then you're throwing good money after bad.
Yeah, a product is part of a build-up, it's part of a system for a particular element, and also that particular element, a wall, for example, is again, that's just part of a puzzle. So it's really important that you don't, you think of the whole house, you think of the whole fabric of the entire building. Essentially, as soon as you start adding something new, it might unintentionally throw something else out of whack or have a negative knock-on effect. Not always. I mean, sometimes it will have absolutely fine. But it's just important to think about that before you start doing stuff. Is like, well, what potential impact could this have elsewhere? And good news is it's not always that difficult to work it out. But just thinking it through is always a good plan before you just start diving into something. Hugh, no problem. Thanks very much for turning up.
Yeah.
I guess a lot of people are thinking about heading off now because we have gone overtime already. So if you need to go, feel free. If anyone has any more questions, we're happy to answer a few more. We won't take it personally if you've already left or are thinking about heading off immediately. Do what you need to do. Thanks for coming. But as I said, if there are any more questions, feel free to fire them in. We'll hang around for a couple more minutes. Again, thanks everyone for turning up. Astrid, James, no problems, Amy. Good to see you.
Thanks, guys. We'll see you all soon.
See you,
Yeah.
Michael. Thanks all.
A lot of very happy people there, I think. Thank you everyone for joining us. And thank you for coming today. And again, another little plea, please do fill out the feedback form and let us know what you thought of today, although the thank yous coming in thick and fast in the comments are I think an indication that people were really happy with the session. So thank you very much to Joe and Jeremy for joining us today. And if you've enjoyed today and you're not already, do consider becoming a member of the Green Register. If you go to greenregister.org.uk, all our information is there, and including information on upcoming events if you'd like to attend one. Oh, I think there's another question in the comments there from Penny.
Oh, what are we looking at? What have I missed?
Going to show a roof build up.
Yeah. Were you going to show a roof build up? There's one on our website. Do you want to run through one quickly? You can go onto our website and have a look. No problem, iPhone. Yeah. We're still sharing our screen, aren't we?
Yeah.
Right.
Yeah.
Let's just see if we come out of this. I'm just going to go onto the Mike Wye website. Is our website come up? Oh, great. So you go into wood fiber insulation and scroll down.
It's on the
There are a series of example build-ups. So you've got some walls there, masonry, timber frame, different finishes, cladding, etc., and a couple of roofs. So is there a particular roof build-up you want to look at? We've got a new build flat roof. The internal pitched roof is a really common one that people want to look at. So if you've got an existing roof that you're tackling from the inside, that's a really common one. But is there one that's particularly relevant to you, Penny? Otherwise, I'll just choose the most easy one. Right, we're going to go into this. Refurb is good. Right, we'll go into this. So, can we go?
read more, yeah.
So it's fairly basic. Essentially, you've got your tiled external roof finish, and you're tackling it from the inside. So if you've got access, or you want to access the rafters, it's important you leave a ventilation gap between the insulation and the underside of your cold tiles, just to allow for moisture and condensation that's probably very likely to occur there to be able to be cleared. And so what you've got here in option A is a partially filled rafter, 50 mil space, and maybe something like 50 or 80 mil of the flexible wood fiber in between your rafter space. And then or the sheep's wool or other natural fiber or other insulation product, and a rigid board on the underside. So that board can be fixed directly to the underside of your rafters. It's essentially, you've got almost like a sandwich now of wood fiber between your rafters and then a rigid board on the underside. And that will, as well as giving you more insulation, that's also a carrier board for your plaster finish. So you don't need plasterboard. It's just wood fiber in between, wood fiber fixed below, and then a plaster skim. There's also a breather membrane You can see that red line, which is kind of woven down and around the rafters
It
before
forms
you
a-
do your install.
So it forms an inverted hammock there, a pocket into which to push your wood fibre.
Yep.
Um,
But that's
The-
by no means the only way of skinning that
No.
cat. There
The
are
other thing you'll see here is where, as Joe said, this is then internal line plaster, the build up, the same as for the wall, 2-3 mil base layers, a 2 mil top coat. In this instance, that's performing the function of the vapor control layer as well. So it's controlling the amount of vapor that can enter that wood fiber to a manageable degree. If you were to want to incorporate a service hatch
void.
underneath there, a service void there, you would need to incorporate a vapor control membrane in there as well.
Yeah. So yeah, that's just one option. Obviously, there's various different internal finishes you might want to go for. This is the same thing, but it's slightly more basic in so much as you've just basically strapped them in a wood fiber board to the underside of your rafters, left your rafters empty. That can be seen as a missed opportunity because you've got that space, you might as well use it. But sometimes if your rafters aren't that deep and you haven't got enough sufficient depth to leave 50 mil, like if you've only got an 80 mil rafter, you might as well just leave them empty and then just purely rely on fitting something to the underside. What you value with this provide, I mean, it really depends on how deep your rafters are and what depth of board you can accommodate. There is, there kind of is no limit, but you can easily achieve like a 0.15 or a 0.18 or a something in that region. That's going to be fairly chunky. I'm not going to beat around the bush. If you really want a really well insulated pitched roof, you ideally want to have access from above. You'd strip your roof and then you'd put a board over the top of your rafters, as well as then have insulation between. Go on, Jez. That a new build? Yeah. So essentially, there.
Oh, no, this is the external.
Is it? Yeah. Essentially, you've got. You can then completely fully. This is a lot more work. It means you're stripping the tiles off your roof. You're probably adding additional height. So in the shape of additional counter battens. That counter batten and tile batten then gives you the ventilation space that you would, in the other example, be kind of stealing out the top of your existing rafter. If you're able to strip your roof and then add more battens on the top side to give you that ventilation space underneath your tiles, you can then fully fill your rafter. You can also put wood fiber board above, so you could go the whole hog. So you could have wood fiber above rafter, wood fiber between rafter, and wood fiber fixed to below rafter. As long as you've then got, as I said, you've allowed for ventilation above all of that, but below your tiled finish. And yeah, you can, if you've got the scope to play around with your roof line, which not everyone has, because obviously that interacts with gutters and junctions and things like that. So you've got to think about all this before you start going to crazy in terms of how much you're going to load on there. But yeah, generally speaking, if you want to get down to a respectable U value, you'll be able to do that from just maybe something like 100 mil in your rafters and maybe a 60 or 80 mil board below. But again, give us a shout if there's something you want us to particularly calculate for you. We'll put that combo together and we'll run it and we'll let you know what numbers it achieves. Hope that helps. That's roofs covered. Flat roofs are a bit more tricky. I don't think we'll get into those right now. There is a detail on our website. A lot of people want to do unventilated flat roofs, but again, ventilation is really key in roofs, so just be mindful of that. There is a detail on there that you can go and have a look at, or you can give us a call and we'll talk through with you. Any other questions? No. Good. Not good, but I mean, don't take that the wrong way.
Excellent. Thank you so much, guys. And thank you everyone for joining us. And we'll let you get back to the rest of your evening. So have a good one. And do consider joining us again at other events. As I say, we've got everything coming up listed on our website, greenregister.org.uk.
Yeah,
So
I second that. When I first started Mike Wye, I basically lived on the Green Register website. I watched all their CPDs. I signed up for everything, and it was good. So I learned a lot really quickly. And it's great to be able to jump back on and kind of give some of that back. But yeah, Green Register, a really good resource. So do sign up, do check out what they've got. There's a huge amount of free information on there, so use it, or email us. Thank you.
Brilliant. Thank you, everyone.
No worries. Cheers, Sarah.
I know.